So let's move into question number 1 of portfolio management. So in portfolio management, there was a topic called efficient market hypothesis, EMH. Okay, whether markets are efficient or not. So there were 3 types of market efficiency: weak form, semi-strong form, strong form. Market is said to be efficient in the weak form if technical analysis is useless, which means you can't make supernormal profit by just looking at past prices. And in order to check whether market is efficient in the weak form, we carry out autocorrelations test or runs test. Now runs test is very, very common. Okay, it has been done in class. Autocorrelation test is less popular, but the best part about autocorrelation test is that you just have to find out correlation. Okay, and correlation coefficient, it is difficult to imagine an SFM student who will not know how to compute correlation coefficient. So let's look at the sum. So as you can see on the screen, question number 1, Mr. X is of the opinion that market has recently shown weak form of market efficiency. That's what he's thinking. In order to test the validity, he has collected following data on Sensex for the past 20 days. Now if you look at the past 20 days, we are given the open, high, low and close. Obviously we are interested only in the last column, that is closing price. Now we come down, you are required to test the weak form of market efficiency using autocorrelations test, taking time lag of 10 days. So which means that from 1 to 10 days, we will find out the change in the closing price. We will get 9 changes, that is X. And from 11 to 20 days, we will find out the change in the closing price, and that is what Y. I repeat, 1 to 10 days, the closing price changes X, and 11 to 20 days, the closing price changes Y. Look at the solution. So in the solution, they have taken the first 10 days. And they've written the closing price and the change. I think in the exam, you can save your time by not copying down the closing price. You just find out the change. Okay. And similarly, they have also calculated Y. From 11 to 20 days, they've written down the closing price and then the change. So we have the X and Y. You understood X and Y? The change in the closing price. Okay, from 1 to 10 and from 11 to 20. Now, I do not want you to prepare the columns that they have prepared. Don't prepare those columns, because then you will be subject to new formulas and you won't like that. Okay. Instead, what did we learn in class? We learned in class that the formulas that you will prepare are first column for X, second column for Y, third column for X minus X bar, fourth column for Y minus Y bar, fifth column for X minus X bar the whole square, sixth column for Y minus Y bar the whole square, and last column for X minus X bar into Y minus Y bar. Correct? You know it because you have done so many times. So if you have these columns, then correlation coefficient is what? It is cov xy divided by sigma x sigma y. So you calculate covariance xy as the last column total, that is summation x minus x bar into y minus y bar divided by n, that's covariance. You calculate sigma x, that is root over summation x minus x bar whole square by n. You calculate sigma y, that is root over summation y minus y bar the whole square divided by n. And then you divide correlation equal to covariance divided by sigma x sigma y. So do not calculate as per the institute unless and until you are ready to learn new formulas. Look what formula the institute has used. These are the formulas A, B, new formulas, and then R square and then R. You can go for it if you are liking new formulas. Instead you calculate correlation by your formulas. Okay. So correlation comes to 0.4 around 0.4. Now 0.4 is not 0. That means the price changes are correlated. That means market is inefficient. So market is not efficient in the strong form. If correlation was 0, we would have concluded that market is efficient in the strong form. You know that actually in an exam, correlation won't actually be 0. So I had given a cutoff like up to 0.2 or 0.25 it comes. Then you take it to be 0. Actually institute has not clarified. So let's hope that either it will be very close to 0 or far away from 0 like 0.4. So market is not efficient in the weak form. Next we come to question number 4 of portfolio management, and that sum is on runs test. Look at the screen. Now runs test, so many times it has been done in class, I'll keep my discussion short. So in runs test we check whether the market is weakly efficient or not. First of all, we mark when the prices have gone up, that is a plus. If the price has gone down, that's a minus, and a series of plus in the same direction or series of minus is called one run. So for example, 2800 to 2780 is a minus, 2780 to 2795 is a plus, 2795 to 2830 is a plus, 2830 to 2760 is a minus, and so on. So everybody knows that. So if you look further down, what's the question saying? With the help of the above data, evaluate the weak form of efficient market hypothesis by applying Run's test at 5% and 10% level of significance. Now, you know that there is something called the T distribution. Okay. And T distribution, we have N1 plus N2 minus 1. That is 18 degrees of freedom, because N1 means number of pluses, N2 means number of minuses. So N1 plus N2 minus 1, from the question it's apparent that there would be 18 degrees of freedom, because the value of T is given only at 18 degrees of freedom. Okay, so whatever test statistic R, okay, the R that we calculate, if it comes to be more than the critical value, that is 2.101 or 1.734, in that case market would be inefficient. Okay, let's check it out. So if you look at the solution, they have marked plus minus plus minus plus minus based on what I said, and then they counted the number of pluses, that's 11, number of minuses, that is 8. Okay, the number of runs, okay, that is 8. Number of runs is the number of series of positive and negative changes that we used to show by brackets. Then they calculated mu is equal to 2n1 n2 divided by n1 plus n2 plus 1. They got 10.26. SD, I don't like this formula which they have given. Our formula for SD was mu minus 1 into mu minus 2 divided by n1 plus n2 minus 1. Understood? That means 9.26 into 8.26 divided by 18, the whole square root. That comes to 2.06. So we have the mean, we have the SD. Okay, we have the mean, we have the SD, and we have the runs. Runs was what? 8. So we'll have to convert the 8 into T statistic. That is, we can do in two ways. One is R minus mu divided by standard deviation, or we can do it via the interval method. Let's see by which method they have done. So they have done by the interval method, that is mu minus T into standard deviation, mu plus T into standard deviation. So they got 5.932 and 14.588. So if R lies between these two, then market is efficient. Okay, but if R lies outside, in that case market is inefficient. So what was our R? The R that we got was 8, and 8 lies between 5.932 and 14.588. So the market is efficient. Similarly, at 10% significant, they got the lower limit, mu minus T into SD, mu plus T into SD. That's 6.688, 13.832. So accordingly, R lies once again, 8 lies in between. So market is efficient in the weak form as per Run's test. I've done it fast because Run's test is something that everybody knows. It's more of a revision. Okay. So let's come to arbitrage pricing theory, APT. You know, APT is like CAPM, but it's not single factor, it's multiple factors. I think it's important for the exam. I've taken a question number 2. Look at the screen. Now this question was done in class, but I consider the question as important. So I've done it in class with you. I'm once again doing it over here. You can see that there are two factors over here, factor 1, factor 2. And they're given two stocks, X and Y. And security Z, you find that the beta is 0, 0. That means security Z is risk-free. So the 10% return given below security Z is actually RF. 10% security Z return is RF. And we are given security X's expected return 15%, security Y's expected return, that is 20%. So what is the equation of the APT? The equation of APT is ER is equal to RF plus FRP1 beta 1 plus FRP2 beta 2. That's the equation. Okay, now if we bring RF on the left hand side, it becomes ER minus RF, that is the excess return, is equal to beta 1 FRP1, beta 2 FRP2. Okay, so we understand all this. Now let's look at the question. In fact, since I've spoken so much, I'll first of all attempt question number 3. Determine the expected return premium on factor 2. So we are supposed to find out FRP2. That we'll find by the simultaneous equation. You just look at the question. There's no need to look at the answer. So for security X, we have excess return 15 minus 10. Okay, 15 minus 10. That is 5 is equal to 0.75 FRP1 plus 0.6 FRP2. That's equation number 1. And for security Y, excess return is 20 minus 10. That is 10. So 10 is equal to 1.5 FRP1 plus 1.1 FRP2. Okay. Now you solve simultaneously both the equations and you solve for FRP2. Whatever you get. Okay, I have a bad memory. I think FRP2 was 0. Let's check the answer. Whether FRP2 was 0, third part. One second, let me go to the answer. On solving, we get the lambda 1 to be 6.67, lambda 2 0. Yeah, FRP2 is 0. And they have calculated security X, security Y return. That's not required. The answer is FRP2 equal to 0. Okay, they've called it lambda 1, lambda 2. So FRP2 is equal to 0. Okay, let's go back to the question. So in the question, the first question, question number 1, analyze the sensitivity of Mr. Kapoor's portfolio. Sensitivity means beta of the portfolio with respect to two factors. Yeah, that means beta 1 and beta 2. If he has 1 lakh to invest, own funds 1 lakh, sells short 50,000 of Y and purchases 1,50,000 of X. So you will remember that in class I told you that weight is equal to what we have invested divided by own funds. So the weight of security X is 1,50,000 by 1 lakh, which is 1.5. The weight of security Y is minus 50,000 by 1 lakh, which is minus 0.5. Always check that the sum of weight should be equal to 1. So weight of X 1.5, weight of Y minus 0.5. And then you can calculate the weighted average, no? Which means the beta of the portfolio is equal to 1.5 into 1.5. Okay, 1.5 is what? 1.5 was the beta of was the weight of X. So the beta 1 is equal to 1.5 into 0.75 minus 0.5 into 1.5. Okay, 1.5 into 0.75 minus 0.5 into 1.5. Okay, that's beta 1. And what is beta 2? 1.5 into 0.6 minus 0.5 into 1.1. Beta 2 is 1.5 into 0.6 minus 0.5 into 1.1. Let's check the answer. So in the answer, they have given the same thing. Okay, the weights. First part 1.5 minus 0.5, and then they've calculated. The answers are 0.375 and 0.35. Next, question number 2. Evaluate the sensitivity of the portfolio to the two factors. If Mr. Kapoor borrows 1 lakh at RF and invest the amount he borrows along with his original amount of 1 lakh in security X and Y in the same proportion as described in part 1. So 1 lakh is own fund, 1 lakh is borrowed at RF, 2 lakh, and 2 lakh is invested in the same proportion as in part 1. So in the part 1, we had invested 1.5 times in security X. So 2 lakh into 1.5 is 3 lakh. So 3 lakh is invested in security X. And for security Y, 2 lakh into minus 0.5, that is minus 1 lakh. So we are shorting Y to the extent of 1 lakh. So now we have total 3 lakhs, 1 lakh own fund, 1 lakh RF and 1 lakh security Y. And the entire 3 lakh is invested in what? Security X. Now what is the weight of security X? 3 lakh by 1 lakh. Amount invested by own funds, which is 3. What is the weight of security Y? Minus 1 lakh by 1 lakh, which is minus 1. And what is the weight of RF? Minus 1. So weight of X is 3, weight of Y is minus 1, weight of RF is minus 1. And you can once again do weighted average to find out beta 1 and beta 2. Okay. So since I had done the question in class, it would be easy for you to capture, but remember that the sum is important. Okay. So let's come to question number 3. Now this sum is on total risk, systematic risk and unsystematic risk of a portfolio, TR, SR, UR. In fact, in this particular handout containing the best questions, I have taken 2 questions on TR, SR, UR. This is the first one, question number 3. Now I have named it ambiguous, though frankly speaking there is nothing ambiguous over here. But the reason I called it ambiguous is because there's a certain portfolio over here by the name of Mix, okay, and they have assumed this to be the market portfolio. That causes some confusion. Many people while reading the question are not able to understand the same. Also, they have confused students between ER and RE. If you remember, ER is the expected or the forecasted return, while RE is the required return as per CAPM. Now in this question, on X and Y, the average return, that is the expected return, is already given in the question. And then once again, they've asked us to compute expected return. So they have computed that by RF plus RM minus RF into beta. So student is thinking then that what was that return which was already given. So logically, the return that you compute as per CAPM, that return is RE, required rate of return. And the return which is already given in the question is expected rate of return. That is the only thing that will ensure that you understand. So in that case, if we were required to calculate alpha, we would have calculated ER minus RE. Okay, although that is not required. Let us get into the sum. You will understand more. So the sum is there in front of you. Question number 3. Mr. Abhishek is interested in investing 2 lakh, for which he is considering 3 alternatives. Invest 2 lakh in MFX, invest 2 lakh in MFY, invest 1 lakh 20 in MFX and 80,000 in Y. That means the weights are 60-40. Correct? 3 options. Average annual return earned by X and Y are 15%, 14% respectively. This is the ER I was talking about. Forecasted return 15, 14. Risk-free rate of return 10% RF. And market rate of return 12% RM. So RM minus RF is 2%. The covariance of returns X, Y and the market portfolio mix. People are losing out this word. It is the market portfolio mix. So mix over here is the market portfolio. So we are given the variance covariance matrix. You know, we have done it in class that the diagonal, that is 4.8, represents the variance of X. 4.25 is the variance of Y and 3.1 is the variance of market. Now, many people don't know this only. In the variance covariance matrix, the diagonal represents variance. Okay. Accordingly, if somebody wanted to calculate beta, okay, beta would have been so easy because the beta of X would be what? The covariance of X with market divided by variance of market. So it's 3.37 divided by 3.1. Similarly, beta of Y would be 2.8 divided by 3.1. Okay, so it's simple stuff. Anyways, let's read the question. You are required to calculate the variance of return from X, Y and market. Now this is a joke because the variance on X is 4.8, variance on Y is 4.25 and variance of market is 3.1. How do we calculate? It's already given. Okay, 4.8, 4.25 and 3.1. That's the answer. Okay, let's check the answer of the institute, how they have done. Now these people have gone mad and God knows what they have done. Ultimately it's 4.8, 4.25, 3.1. You can check the answer. Let's go back to the question. So the first part you don't have to calculate. The diagonal is the answer. 4.8, 4.25, 3.1. Question number 2. Calculate the portfolio return. So the portfolio was the mixed portfolio. Okay, 60-40 weight. And the return on both the funds were 15 and 14. So portfolio return is 0.6 into 15 plus 0.4 into 14. Calculate the beta of the portfolio. So 0.6 into the beta of X plus 0.4 into the beta of Y. I already taught you how to calculate the beta. The beta of X is 3.37 by 3.1. The beta of Y is 2.8 by 3.1. I am speaking all this from the question. Okay. So accordingly, weighted average is the beta. Portfolio variance in SD. So portfolio variance, weight square into variance, weight square into variance, 2 into weight into covariance. So that means 0.6 square into 4.8 plus 0.4 square into 4.25 plus 2 into 0.6 into 0.4 into 4.3, the whole square root. Let me show you the answer. Let's come to the answer and see the standard deviation portion. So standard deviation portion, we come to the answer. Yes, here the institute has done 0.6 square into 4.8 plus 0.4 square into 4.25 plus 2 into 0.6 into 0.4 into 4.3. That's the variance and the square root is 2.115. Okay, let's go back to the question. If we come back to the question, they're asking us to compute the Sharpe ratio, Trenner ratio and alpha for X, Y and, third question is expected return, systematic risk and unsystematic risk. Okay. Expected return over here means required return because the expected return was already given 15 and 14. So they're asking the required return as per CAPM, that RF plus RM minus RF into beta, all the figures you have. So they asked us the expected return. What did they ask us? Systematic risk is beta square into variance of market. And unsystematic is total risk minus systematic risk. So very simple. Fourth question, Sharpe ratio. Sharpe ratio is excess return to beta. Trenner ratio is excess return to SD. Alpha is ER minus RE. Okay, of X, Y and portfolio mix. So please do the question nicely. It's very likely to once again come in the exam. Okay, very important sum. So this is question number 12. The second question on TR, SR and UR of a portfolio. And this has no ambiguity. Okay. In this question, we are given 3 stocks, D, E and F. Please look at the table. The weights are given, the beta is given. So the first thing is that you can do weighted average and you calculate beta of the portfolio. Return is given. If you want the return, you can calculate weighted average. You can get the expected return of the portfolio. Variance is given. You can't do weighted average, okay? Because we don't have a formula called weighted average variance. Now, below the table, SD of the market is given 10%. So what would that be used for? In case we require systematic risk. So beta square variance of market, we'll get the systematic risk in case we require, okay? You are given the following data. Covariance of D with E, covariance of D with F, covariance of E with F. Now this is the Markowitz covariance, okay? Because do you remember? The covariance according to CAPM is beta A into beta B into variance of market. If some of you remembers, CAPM believes that we don't find out the covariance of any pair of stocks. We believe that all stocks are correlated to each other because of market. So for instance, if I were to calculate the covariance of D and E, covariance of D and E as per CAPM, it would be beta of D, which is 0.4, into beta of E, which is 0.5, into variance of market, which is 10 square 100. So 0.4 into 0.5 into 100. That would come to 20. Okay. Of course, when I say 20, it is 20 square. That means percentage square. Whereas the 0.03, which is given over here, is 0.03 into 100 square. 0.03 into 100 square, which is what? 300. Okay. That's the covariance which is given over here. Okay. So you have to be very careful about this thing. The total variance also, which is given in the last column, is supposed to be multiplied by 100 square to get it into percentage square. So that 0.015 is actually 0.015 into 10,000, which is what? 150. 0.025 is what? 250. Okay. And 0.1 is actually what? 1000. So that's 150, 250 and 1000. Okay. So you got to multiply variances with 10,000 to get percentage square. Be careful about that. Anyways, I have not yet read the question. The question is calculate the portfolio variance considering correlation between each pair. That means the Markowitz approach, and co-movement between securities due to change in the market index. Now that's the Sharpe index approach. Do you remember there was an earlier question where they had mentioned calculate the portfolio variance as per Markowitz and as per what? Sharpe. So in Markowitz, we use the covariances that are given. In Sharpe, we don't use the covariances. We can calculate covariance by beta A into beta B into variance of market. So now what I would like to tell you is the easiest way of solving the sum. If you just look at this question, do not look at the solution, just keep the question open, okay, is that we apply that variance of portfolio formula, which is weight square into variance plus weight square into variance plus weight square into variance, okay, plus 2 into WD WE into COV DE plus 2 into WE WF into COV EF plus 2 into WD WF into COV DF. Understood? That way. But where I am afraid is that when you apply this formula, either take everything in decimal or take everything in what? Percentage square. I think over here everything is given in decimal. So don't spoil it. Take everything in decimal. So for example, my figures would be 0.2 square into 0.015 plus 0.5 square into 0.025. I hope you are looking at the question. I am looking at the question, not the answer. 0.2 square into 0.015 plus 0.5 square into 0.025 plus 0.3 square into 0.1. Correct? Now plus 2 into 0.2 into 0.5. That means weight of D into weight of E into 0.03, the covariance. Then let's come to D and F. 2 into 0.2 into 0.3 into 0.02 D and F. Now 2 into 0.5 into 0.3, that is E and F, into 0.04. Okay, that's how they have done. Let's check. Okay, let's check their solution. The first part is very, very simple. If somebody cannot do calculation, then what do I say? So this is what I was saying. Weight square into variance, weight square into variance, weight into covariance. Okay, and so on that they have done. You have to compute. Let's hope that the answer is matching 0.0363. 0.0363. Okay, I don't know. Okay, yes, it's matching. The student sitting beside me is saying that yes, sir, it's matching. 0.0363 is the correct answer. No need to take a square root. They're asking you to calculate portfolio variance. Now, let's go back to the question. If we go back to the question, second part, we have to use co-movement between the securities due to change in market index. Now, they have done this solution by a particular method, which is correct. But I think it could have been solved easier. How? You calculate new covariance between D and E. What would that be? Look at the data. It would be 0.4 into 0.5 into 100. Okay, beta D into beta E into 10 square. That comes to 20, but take 20 as a decimal better. So 20 by 10,000. 20 divided by 10,000, what is it? 0.002. So you take the covariance DE to be 0.002. Now let's go to DF. 0.4 into 1.1 into 100. 0.4 into 1.1 into 100. That comes to what? 44 divided by 10,000. 0.0044. 0.0044. And the third one, E and F would be 0.5 into 1.1 into 100. 0.5 into 1.1 into 100. And this comes to 55. That is 55 by 100. 0.0055. Okay. So these are the covariances. Then you can once again use the formula. But they have done it in what manner? They have illogically computed. Okay. Let me not show the answer. Let me concentrate on the question only. I mean the question only. They have calculated the systematic risk for D, which is beta square into variance of market, systematic risk for E, systematic risk for F, and then unsystematic risk is total risk minus systematic risk. They calculated for DEF. Then they calculate systematic risk for the portfolio as beta square into variance of market for the portfolio. Then they computed unsystematic risk for the portfolio. I think it could have been better done by the same method as part 1, but just calculate the new covariances. Please try the same and match the answers. Okay. Of course, if the answer doesn't match, I don't think that would be an eventuality. If it doesn't match, you have to follow the institute. Okay.